Okay, we are talking about second type of questions. First question I have done, both blocks are moving vertically. Now we'll talk like how blocks are moving. Blocks moving like vertical and horizontal both. Vertical and what? Horizontal. Should write the first type of question, both blocks are moving vertically. Okay, how it looks here? Suppose some blocks are placed on table. This is a table, and some block is placed here M1. Tied to string. This is your pulley. Okay, pulley supported here, and passing our pulley and other masses what hanging from this table. This is a table, frictionless table. All the problems we are doing here, we are assuming no friction. Once we learn the friction force, then we include all this problem with friction. This is your M2. Okay, yes. Now what will happen? One block on horizontal table, which is what smooth, no friction at all, and one block is what vertical. Okay, yes. So here in this case, it doesn't matter like whether this block is bigger than that or smaller than that. In every case, it will move down only if this surface is what smooth. Okay. So this block is moving down with acceleration a, and this block is moving in this direction with what acceleration what a. Correct. Again, question is same. Calculate tension in the strings. Calculate acceleration of the system and reaction at the pulley. Okay. All three questions again. Okay. Give attention. Let's calculate first acceleration of the system. What is the acceleration of system? A says that is net force by what? Total mass. Okay, so this block is moving vertical direction. Which force is making it move? M2G. M2G. This is a force that is making it move downward, right? But now you cannot write here minus M1G. Correct, na? Because that block is moving what? Horizontally. Last time when two blocks are moving, one moving down, one moving up, you wrote the weight going down like M1G minus the weight going up. But here this weight is moving what? Horizontally, and it's a smooth surface. So just this much are the only force which is pulling this system by total mass M1 plus M2. Correct? Okay. Suppose friction was given here, then friction will be opposing force. You have to write friction here. M2G pulling down minus friction that will try to stop this system. But right now it's smooth surface, so only this is the force which is pulling this system what? Downward. Okay, this is the acceleration of the system. Okay, now you have to find tension. You have to take same way the FBD. Exactly same way you have to do what? FBD. How? Suppose this is a tension T. Here also what? Tension T. Okay. Yes. Let's write FBD of M2. FBD of M2. Because one string you can take FBD of that block. You can take FBD of that block. Answer will be exactly same. M2 you are taking FBD. Then how it looks? This is a block M2. Moving vertically, this is the force tension T, weight force M2G downward, and acceleration A is what? Downward. Okay, so what is the answer here? You write M2G minus T is equal to what? M2 into what? A. So tension will be this one, M2G minus M2 into A, M2G minus A. You don't need to remember any formula as a formula, you have to understand how I am doing, right? Yes, because 1000 possibilities are there, you have to understand how we are writing FBD. So same answer you can get if you write FBD of this block also, right? That's moving horizontally. Suppose you write FBD of that block, then how it looks? FBD of M1 block you write. That is moving horizontally, so you should write it horizontally. This is M1. Here is tension T, and here is what? Acceleration A. No other force. So tension directly equal to what? Just M1 into A. That's more easier than what? These steps. Correct? Okay. Now you watch third question, what? Reaction at the pulley. Reaction at pulley we have to calculate, right? So you cut the pulley and write here. So watch carefully. Pulley will look like this one. This is a tension T on this side. This is a tension T on this side. And here reaction, if you want to say like this, R reaction. So in this case, like last we have done, both blocks are moving vertically. So reaction R is equal to simply the T1, right? But here give attention. R is just not directly to T1, T2 because these two forces are what? Perpendicular to each other. First you have to find sum of these two forces which are at 90 degree, correct? So sum of these two tension, what is the answer? T days. Our formula root A square B square plus 2AB cos theta. This formula is used for vector addition. Any vector you want to add, you have this formula. So these are two forces, you want to add them. So what is the answer? Root T square plus 2TT and cos 90. Cos 90 means that term directly becomes 0. So what is the answer? Root 2 times of the T. Correct? So total force of these two will be root 2 times of T. So reaction here will be R will equal to what? Root 2 times of T. Yes or no? So whatever the angle given here, you have to write correct. Last time we have done like both like this way, correct. So here angle between these two is what? 0 degree, between this tension and this tension. So when write this formula again, cos 0 means become 1, so become a square b square plus 2ab means a plus b whole square means simply a plus b. So means t1 and t1 you added 2t, that's all, correct. Okay. So these are what? Blocks moving horizontally. Let's do a numerical on this. Okay, suppose this is given, problem 1, and they said calculate tension in strings, acceleration of system and reaction at what? Pulley. Okay, so let's write this is table and some blocks are given. Let me write 2-3 blocks, one block here, one block here, then they are passing over a pulley, this is a pulley, and one block here. Let's write one block what? Here. Okay, yes. Let's call this block as 2 kg, this block as 3 kg, this block as 5 kg, and that block also, let's say anything, okay, say this as 10 kg, doesn't matter. Okay, yes. Name we give M1, M2, M3 and what? M4. Okay, tension here let's call between these T1, tension here let's call T2, that will also T2, and tension between this string let's call what? T3. Okay, yes. So we have to calculate all the tension, the strings, and acceleration of the system and the reaction at the pulley. Let's go step by step. First calculate the acceleration of the system. Correct. Again this surface is what? Smooth, no friction. Okay, these systems are moving downward, these blocks moving downward with acceleration a, these are moving horizontally with what? Acceleration a, correct, same acceleration. Okay, so net force by total mass. So these who is making move to the system, these two weight which are moving downward, 5 kg and 10 kg. So I am writing directly 15 kg, right? Should I write like M1, M2? That's the waste of time. So 5 and plus 10 kg, 15. 15 means 150 Newton. That force is making the system what? Move downward. No opposing force because these are moving horizontally. No friction there. By total mass 2 plus 3 plus 5 plus 10. So 150 by how much this comes? So it becomes what? 20. Okay. So that's your acceleration. How much acceleration? 15 by 2 meter per second square. Okay. This is the acceleration of the system. Okay, done. Now we have to calculate tension in the strings. We have 3 strings here. We have to calculate 3 tension. Let's calculate. Okay, let's calculate first T3. That's easy. So FBD of M4 you writing. When write FBD of M4, how it looks? This is what? 10 kg block. Tension T3 is upward. Mg is downward and accelerating what? Downward. Okay. Yes. So mg minus T3 is equal to what? Ma. Mg means what? 100 Newton. 10 kg means 100. T3 you have to calculate. 10 into acceleration we have found here what? 15 by what? 2. 2 goes 5. So 100 minus 75. That's what your T3, or T3 becomes what? 25 Newton. That's your first tension in this string. Okay. You can calculate T2. You can calculate T1. Let's calculate T1. So you're writing FBD of M1 block, the block which is moving horizontally, that's what here, 2 kg block. I'm writing FBD of this block, moving this direction, and here tension T1 and acceleration what? A, no other force. So T1 is simply equal to what? Ma. M is 2, acceleration we have calculated here, how much? 15 by 2. So this force becomes what? 15 Newton. So this tension is what? 15 Newton. You want to calculate T2, you have 2 methods. You can take FBD of this block, you can take FBD of this block. Your choice. Okay. Okay, let's write FBD of anything. Let's write FBD of that 3 kg block. So FBD of M3 I am writing. When I write M3, how it looks? This is 3 kg block. Okay, here tension T1 and this side tension T2 and accelerating horizontally like this one. They are moving this direction, so T2 is big. T2 minus T1 is equal to what? Simply what? Ma. So we have to find T2, right? T1 already we know. How much T1? 15 Newton is equal to Ma. 3 into acceleration we have found what? 15 by what? 2. So 45 by 2. So T2 is nothing but 15 plus 45 by 2. This becomes 30, and 30 means what? 75. 5 by what? 2 Newton. Same answer will get if you write FBD of this block. You try this, okay, and check it. Now last question, what is remaining? That what is the reaction at the pulley? Okay, let's write FBD of pulley. When write FBD of pulley itself, how it looks? This is your pulley, one force here, that's called tension T2, one force here, that's called tension T2, and what will the reaction here R. So again, two forces are perpendicular and equal values, use same formula, it becomes root 2 times of that value. So R simply equal to root 2 times of T2. So root 2 times of T2, T2 we have calculated somewhere here. So 75 by 2, or you said 75 root cancel here by root 2 Newton, that's your answer. Correct? So hope you are understanding these problems. Blocks moving what? Some blocks moving horizontally, some blocks moving vertically. What's the main change here? When write acceleration here, you have to give attention here. These blocks are moving downward, they are pulling system downward. These are not opposing, correct? No? They are moving horizontally. So here you write only the force which are driving the system, these are the weight which are hanging vertically only, okay? Okay, let's see this example. Question remains saying, again, three things only you have to calculate always: tension and acceleration and what? Reaction at the pulley. So calculate tension in the strings, acceleration of system and reaction at pulleys, okay? Yes. So this picture is given, suppose now this is a horizontal table, suppose, and there are two pulleys, one pulley here, one pulley here, pulley number 1, pulley number 2. One block is hanging here of M1, this block is calling M1, some value 10 kg. Okay, one block is what? On the horizontal surface, that I am calling M2, let's say is 5 kg. Another block is I am saying here, let's call this M3, and this mass I can write as 15 kg. Okay, now give attention. Two pulleys, n number of pulleys you have, nothing will change unless they are moving pulley. Okay, fixed pulleys, any number of pulleys you have, our acceleration will be same everywhere. Okay, yeah. So here we have two string, one string that string, one string this string. Here let's call tension T1. Okay, T1, that string let's call tension T2, let's call T2. We have to find tension in the strings, and you see these two blocks are moving vertically, that block is moving what? Horizontal, right? Yes. Okay, so let's start. Same calculation. First we have to calculate acceleration of the system. Acceleration, okay, A. Net force by what? Total mass. Okay, that's 10 kg here, 15 kg here. It means this system will move downward, that block will move upward with the same acceleration, and this block will move horizontal with what? Acceleration A. Correct? This going down, that going up, that moving what? Horizontally. Okay, there may be even more block here, doesn't matter. Okay, so let's write. Who is making the system move? This block 15 kg. So I am writing like M3G is making this system move downward, right? This is making motion, and who is opposing this? This weight. This is hanging vertically, this is opposing, this has no role. Okay, so minus that weight M1G by total mass M1 plus M2 plus M3. This is not playing a role in causing motion or stopping this, but still total mass it will come. Okay, yes. So let's calculate here. A will be M3G, this becomes what? 150 Newton, M1G becomes what? 100 Newton, and that becomes 10 plus 5 plus what? 15, so it becomes 50, and how much this becomes? 20 and 30, okay, yes. So acceleration of system is what? 5 by 3 per meter per second square, right? This is the acceleration of system. Even you have attached one more block here or one more block horizontally, doesn't affect your calculation, same way you have to follow. Okay. Now we have to calculate tension in the strings, okay? Yes. Okay. So tension we are calculating, we have to take what? FBD. Let's take FBD. So T1, you cannot take FBD of this one because T1, T2 both are unknown. You can take this and this block, your choice. You are writing FBD of M1. When write that one which is moving vertically, let's write it here. So that block, 10 kg block, tension, what we call that? T2 we are calling upward, weight downward, and is accelerating what? Upward with acceleration A. So what's the equation here? T2 minus mg is equal to what? Ma. T2, mg means 10 kg block become 100 Newton, m into g, MA, 10 into acceleration we have calculated somewhere here, 5 by what, 3, this becomes 50 by 3. So T2 is nothing but 100 plus 50 by 3, this becomes 350, so 350 by 3 Newton, that's the tension T2. Okay, now let's calculate what, tension T1. You can take ABD of this block, you can take ABD of this block, because T2 we know, your choice. So I am taking this one easier, you try with this, okay, yeah. Let's write ABD of M3 I am writing. So how it looks, moving vertically, so this block, your 15 kg block, tension T1 upward, mg downward, and is accelerating downward, the acceleration A. So what is the equation here, mg minus T1 is equal to what, ma. Mg means 15 kg becomes 150 Newton, T1 m is 15, and acceleration already we wrote somewhere 5 by what, 3 goes 5 times, this becomes 25, so T1 is nothing but 150 minus 25 means 125 Newton, right? Okay, this is the acceleration here, and you take the ABD of this block moving this direction, so you should get the same answer, check it. Okay, last question was reaction at the pulley. Okay, this is a pulley number 1, that's pulley number what, 2. So the reactions will be different because forces are different, pulley number 1 and pulley number 2. So when you talk about pulley number 1, that pulley on left side, pulley 1, how that ABD looks, this is a pulley, one force here T2, one force here what, T2, that's the reaction here R. Again you see two forces are perpendicular to each other, same vector rules you have to use, root a square b square plus 2ab cos theta. Okay, so you will get same answer. So reaction will be root 2 times of this for T2, root 2 times of T2 we have calculated somewhere, that's what, 350 by 3 Newton, that's your answer. Same you take ABD of this pulley also, I am writing directly, when you take ABD of this pulley, how it looks, this is a pulley, this is a tension T1, this T1, that's tension what, T2, and let's say this reaction R. Again two forces are perpendicular and exactly same force, so again R becomes what, root 2 times of T1, root 2 times of T1 we have calculated somewhere 125 Newton into 125 Newton, that's your answer, right? Yes. So n number of blocks, then moving horizontally, vertically, you have to follow the same procedure, right? Okay. So now this is second type of questions. First type of questions, all blocks moving vertically. Second type of questions, moving horizontal, vertical combination. And third, on an inclined surface now we'll talk, okay? Yes. So when we are talking inclined, how they look? This is the third type of question doing on pulley system. Blocks on what? Inclined surface. Okay, it means like this one, maybe like this. Oh, I drawn it very badly. This is an inclined surface, some angle theta. Say one block is placed here, one block, two block, and some pulley say here. So this string is passing over pulley, and other block is what, here. Say this block is what, M1, this is what, M2, correct? Okay, this is your pulley here, yeah. Okay, question remains same, calculate the acceleration of the system, calculate the tension in the strings, calculate the reaction at the pulley. Okay, so same procedure only you have to follow, ABDs. Okay, look here, first, who is moving down, who is moving up, that you have to see it here, okay? Yeah, here like masses may be equal still, they moves up and down. So depends on what, look here, okay, who, suppose, up I say I am moving, I am moving down with acceleration A, then this moves upward acceleration with what, A. How? This will move down only if, what will happen, M2 is greater than what? Look here, what's opposing here, not M1, is writing M1, you should write, or write weight, let them write M2G, I should write weight for M2G, this weight of this block is greater than what? Component of that, mg sin theta, right? Then this system will move down, okay? Yes. Or suppose this is more, M1G sin theta is more than M2G, then this will move down, that will move what? Up, correct? So this you can check, yes. Okay, like we have checked now, suppose now I am saying that this is given, okay? If, suppose this is true, okay? Then what will happen? Let's calculate acceleration of system. Okay, this mass is going down, this is making this system to move downward, so m2g is making downward, and this is what opposing this, m1g sine theta. So m1g sine theta, again I am assuming no friction here, by total mass m1 plus m2, that is the acceleration of this system first. Okay, yes, then we have to calculate tension here T, and here what, T, there is only one string, correct. Okay, once more let's see the acceleration. Either this is moving down, that moving up, or opposite, this is moving down, that moving up. This can happen, doesn't matter. Even you writing wrong, your answer will become just negative only. Okay, you should not worry, you can write anything. Okay, now we have to find tension. You have to write FBD. So when write FBD, that FBD will be easier of this block, vertical, that also you can write. Both ways you should get the same answer. So for writing FBD of M2 you write, then how you will write? Look, it's moving vertically, so M2 block here, tension T upward, and M2G is downward, and what, acceleration A downward. So answer is what, M2G minus T is equal to what, M2 into A. From here you can calculate your answer, right? I am just writing equation only, but same answer you can calculate if you write FBD of this block. Suppose you write FBD of M1 you writing, then how it look, inclined surface is there, so along incline you write equations M1, this component is what, your M1G sine theta, that is what your tension T, and acceleration A along this incline, right? So what is the equation here? T minus M1G sine theta is equal to what, M1 into A. This equation you will write, you will get your answer. So this and this both will give same answer because there is only one string here, correct. Now important, reaction at Pulley. So when you write reaction at Pulley, you will take FBD of what, Pulley. Okay, yes, and how it looks, you took that, cut it from here and take it, so it look like that way, that, and what, this one, right? Yes, yeah. So this reaction you have to calculate, that's what tension T, that's tension T. So you need what, this angle you need, theta. That angle you have to calculate. What is that angle? Suppose this angle is already 90-degree right angle always. This angle is given to you, so you can find that angle, right? This is theta given, you can call this alpha some name, okay? So this angle 90, that is given to you, so you can find that angle. Then you vector rules again to find R. R will be equal to what? Square root of this plus this. So you write like T square plus T square plus 2 T1 T2 and cos alpha, whatever angle that here, that you will write it here, right? Okay, I will discuss some numerical example on this now. Okay, let's do some problem based on what, that blocks moving on an inclined surface with the help of Pulley. Okay, let's say problem number 1. Question remains 3. 3 questions are possible. Calculate tension in strings, acceleration of system, and reaction at Pulley. Okay, reaction at Pulley. Okay, suppose this picture is given to you. Okay, this angle is given 30-degree, and there is a pulley here. Some blocks are connected by that pulley. Let's call that M1. Let's call that 10 kg blocks, and one block, let's say here 20 kg block. Another block, let's say here what, 20 kg block. Okay, this block I am calling M2, that block I am calling M3. So for this system you have to calculate your tension in the strings. There are 2 strings, and acceleration of the system and reaction at the pulley. Let's calculate all this answer. So let's give some name. This string I am calling tension as T1, that string let's call T2, here also in what, T2. Okay, so obviously this weight will be going down, you can check also, because the component of that pulling it downward is what, mg sine theta, right? Mg is what, 100, right? Sine theta means sine 30 becomes what? So it becomes 50 Newton, but here you see it's very big, 20 plus 20 means 400 Newton, okay? So this force is what, big, okay? Okay, let's calculate. So first calculate the acceleration of the system. So you have understood that this system is going downward, and that's moving what, along the incline like this way, okay? Acceleration A. What is acceleration? Weight which are pulling system this down, these are 2 weight. So M2G plus M3G, and who are opposing this, the component of this, which is what, M1G sine theta, M1G sine theta, by total mass M1 plus M2 plus what, M3. Okay, M2G, that one. If you want to change this value, you can change also, but let's keep it same, doesn't matter. Okay, so M2G means what? 200 Newton, M2G also 200 Newton, and how much that becomes? This is what? Mg sin theta. Mg means what? 100, sin 30 means 1 by 2, so this becomes what? 50 Newton by total mass 10 plus 20 plus what? 20. So this becomes what? 350 by this becomes what? 50. This get cancelled here, 7 meter per second square, that we getting acceleration of the system, right? Now let's move on to the tension, how to calculate tension. So you have to take FBD. Easiest will be T1 by taking FBD of this. So FBD of M3 you are taking, then how it looks? This is what your 20 kg, right? M3. So Mg is acting downward, tension T1 upward, and accelerating what? Downward, acceleration what? A, right? Okay, what is the answer? So moving downward means here Mg minus T1 is equal to what? Mv. Mg means what? 200 Newton minus T1, 20 into acceleration we have calculated here 7. So T1 becomes what? 200 minus 140. Correct na? Correct, yes, correct only. So 60 Newton is the tension T1. Okay, T2 you want to calculate, you can take FBD of this, you can take FBD of this, your choice. Both ways should get the same answer. Suppose I am taking M2. I am writing FBD of M2 block, which is moving vertically. This is your 20 kg block, tension T2 upward, Mg downward, and tension T1 downward, accelerating downward, right? So what is the answer here? Mg plus T1 minus T2 is equal to what? Mv. These forces are downward, upward, is equal to Mv. Mg means again 200 Newton, 20 into 10. T1 we have calculated already, that's 60 Newton. T2 we have to calculate. Ma 20 into acceleration we found somewhere where 7. Okay, so this becomes 260 minus this is what? 140 is what? T2, or T2 becomes simply 120 Newton, right? Yes, same answer should get when write FBD of this block also. You try this, take FBD of this block. So what force are acting? Tension T2, Mg sin theta, and acceleration what? Upward, right? So T2 minus Mg sin theta is equal to what? Ma. You should get exactly same answer. Okay, now final question, what? Reaction at the Pulley. What is the reaction at the Pulley? So reaction at Pulley, you will take FBD of the Pulley. So you will see Pulley looking like one. There is one T2 here, and this is what? T2 here. This angle we need theta, okay, alpha whatever, yes. So this angle 30 degree, this angle 90 degree, that angle should be what? Obviously 60 degree, correct? Okay, so these two forces are same, T2, T2, that already we calculated 120 Newton here. So when write in a vector formula, like you don't put the values, suppose this you call what? X, right now? So A and B, this force and this force both are same. So you write in like x square plus 2, x1, x2 means x square, and cos 60. Cos 60 is what? 1 by 2. So cos 60 1 by 2 means this get cancelled, we get what? Root 3 times of the x. So root 3 times, reaction we getting root 3 times of T2. So root 3 times of T2 already we calculated 120 Newton, correct? Yes. So these are two forces T2 to T2, they are acting at what angle? 60 degrees. So I took vector sum of them by writing vector addition formula, root a square b square plus 2ab cos theta. That's the reaction at this Pulley R here, right? Okay, okay, let's do one more question. Similar problem, okay? Yes. Okay. Suppose same question it will be calculate tension and strength, acceleration of system, you write it completely, and reaction at what? Pulley, okay? Please write this question properly, okay? Suppose this system is given to you. This is given 30 degree, say this is given what? 60 degree. There is a pulley here, one block here of mass, let's call this M1 block, and one block here, there may be two block, doesn't matter, this block M2. And suppose given to you, they can give numerical value, or given that M1 is equal to M2 is equal to what? Simply M. This is given to you, or some numerical value, or maybe these different, correct? So we have to find what is tension in the strings, what is the acceleration of this system, and what is the reaction at the pulley. Again 3 questions, okay. So first you have to understand that which block is going up and which block is going down, correct. Okay, mass are given equal, both are mm, right. So whose component is weight component is big, that will go down. So component of this is what, here m1g sine theta, here is what m2g sine theta, right. So who will be big? Obviously mass is given same, so mg becomes same, depends upon sine theta. So this is sine 30, this is what, sine 60, right. So sine 60 has a bigger value because sine 30 is 1 by 2, that becomes root 3 by 2, which is bigger. Means this system will move downward because mg sine theta, this force is what, bigger than what, this one, right. I am writing as m1g sine theta is bigger than what, m2g sine theta. So this system moves down, that system moves what, up. This is the one thing, okay. Yes. Now let's calculate acceleration of the system. What is acceleration? A, same formula, net force by total mass. Okay, this component weight, the weight of this block is trying to move this system down. So what is the answer? m1g sine theta, correct, that theta, yes, minus this weight is what, opposing, so it becomes m2g sine theta by m1 plus m2, correct, yes. Okay, just we have to put values here only. Mg is exactly same only, or it may be different also. Sine, this I give some name, this is what, theta 1, this is theta 2, otherwise you confuse, theta 1, theta 2, okay, theta 1, theta 2, some name. Okay, sine theta 1, what is sine theta, what, sine 60, which is what, root 3 by 2, and this is what here, 1 by 2, okay, by what, m plus m is what, 2m, this m goes here. So we are getting some answer here that you can simplify this, we are getting g by 2 here, okay, and this becomes root 3 minus 1 by what, 2, okay, you can write what, 1, root 3 is what, 1.7, minus 1 you can write 0.7 by, this becomes 4 into what, g, or you can write 7 by 40 g, your choice. You can keep the same also like this, like that, your choice, okay. Okay, then let's find tension in the string now. So tension, you have to take what, FBD, you can take FBD of any block, your choice, because there is only one string, here T, here also what, T. Suppose you write FBD of M1, how it looks. Yes, this FBD will be here, this is your block M1, here force is what, M1g sine theta, the block here is what, tension T, this is moving down with acceleration A. So same, just you write equation, you will get your answer. So what is the answer? M1g sine theta 1, okay, minus tension is equal to what, M1 into what, A. That gives answer. Acceleration already we have calculated here, okay. So you can put in this equation to get your answer of the tension, or you can write FBD of this block also to get the same answer. Now you have to get reaction at this pulley here. Reaction will be these two forces. So how you will answer reaction question? Same, you take FBD of the pulley is here, one force here, that's we calling T, one force here, that we calling what, T. So two forces are acting at this angle, so that angle you have to calculate. This is 60 degree, this 30 degree, so that angle will be obviously 90 degree. So these two forces are acting 90 degree, you will calculate first tension from here, then same rule, okay. R will be equal to the vector sum of these two forces, so you write same one, root A square B square plus 2AB cos theta, right, and you will get your reaction answer. So this were all about the fixed pulleys, right. In fixed pulleys, you have one pulley or two pulley or 10 pulley, it doesn't matter. The acceleration of all blocks will be exactly same, correct. So we'll talk little about now movable pulleys. They did not ask any question to our exam so far, but we'll get the basic idea about that, okay.